All right, so just going to talk you through how to do your assignment on correlation. Okay, there's everything that is required for the assignment. There's no need to take it down or anything from the video. I have it posted up on the Schoology page already. I'll show you where to find that towards the end of the video. So you need to draw a scatter plot using real world data. Okay, so you've drawn scatter plots. You would have done them a couple of times in class before we finished up. It's pretty much all we got a chance to get done in class before we finished up. And there is also videos just talking through how you do them as well, which I've posted on Schoology, so you can kind of scroll back through the updates to find those. Okay, but your scatter plot should look something like that. Okay, so you do have to find the data yourself. That nearly will be the hardest part of this assignment, but once you've got that data found, draw your scatter plot. It'll look something like that. All right. I want to see that. So I don't just want the scatter plot. I want kind of a table with the data laid out as well. So tell me, kind of put the raw data in as part of your assignment, and just tell me where you found it. So if you found it on some website, tell me what that website is. Okay, once your scatter plot is drawn, I want you to describe the correlation. Okay, so again, there's kind of videos and stuff on Schoology on this, but you're going to talk about the strength and the direction of the correlation. So just to take this one as an example, that's positive correlation because it's going up from left to right, and I would describe that as strong because it's very, very close to forming a straight line. Okay, if it was a bit more scattered, you might say moderate, even more scattered, weak. If the dots were all over the place, you'd say there's no correlation there. All right, if it's going down from left to right, negative, and the same sort of words like strong and moderate and weak. Calculate the correlation coefficient using the online calculator. So that's that number between -1 and +1, which tells you exactly how strong the correlation coefficient is. Okay, there is a video up showing you how to use that online calculator to work out the correlation coefficient, and there's a video then talking about what it actually means as well. Okay, so just whatever data you use to draw the scatter plot goes into that online calculator. It's linked elsewhere on Schoology. It will spit out the correlation coefficient for you. I want you to describe the correlation in the context of the data. Okay, so you're describing it as strong, moderate, strong to moderate, positive, whatever. But talk about it in terms of what your data is. So I think this scatter plot here is it's time spent with customers and the amount of sales you make to them, I think, or something like that. So you would say, based on this scatter plot, the more time a salesman spends with customers, the greater the sales made to the customer, or something like that. Okay, so as well as kind of just abstractly saying it's strong, positive, say what it means. Okay, more time spent, more money made, or whatever it is for your question. Identify obvious outliers on your scatter plot. So there's none on this one, okay? But let's say there was a point over here, okay? So someone spent loads of time with one of the customers and didn't get too much money out of them. All right, so you would describe this as an outlier. So all the other points are kind of tightly packed around some straight line there, but one is quite far away. So you would say the person who spent 6 hours on however many minutes that is roughly and only sold 1,800 euros worth of whatever it is to the customer are an outlier. Okay, so just identify which one the outlier is. I think it will be a good idea then to go back and work out the correlation coefficient without them as well. So you would have got a number for the correlation coefficient with this. That will make it a lot lower than it should be. So it might only be like 0.3 when you have that one in. But if you take that out of your calculation, you might get 0.95. So then you could say there is a strong correlation here, except for the outlier. Okay, so if there is an outlier there and you can do that sort of stuff, that's kind of making your assignment really good and kind of that kind of nuance, that detail that you'd be putting in. Next is just your line of best fit. I didn't give you too much kind of detail on that, but you've kind of seen a line of best fit on a lot of the scatter plots you've done. So line of best fit is just kind of on this one. If that outlier wasn't there, say, it'd just be that. If the outlier is there, they might just drag it down a little bit towards the outlier. Okay, but line of best fit, just draw it by eye as best you can. Don't worry too much about that. All right, but that's what is required for your assignment. I'll just talk through it in a little bit more detail now. So as I said, I think the hardest part will be finding your data. Okay, once you have that, kind of what you do isn't a huge amount. What you need to do isn't a huge amount. So just remember, you need bivariate data. So that means you need two pieces of data about the same people, the same years, the same countries, the same teams, etc. So to do this, for example, let's say you were doing height and weight. Okay, you would need the height and weight of 12 different people. Okay, so you maybe get say 11 players in the Liverpool starting 11 on the manager. Okay, so get the 12 of them. You need the height for each of them and the weight for each of them. Okay, you're not going to get the heights for Liverpool players and the weights for Manchester United players and put them on the same scatter plot. Okay, so it's two pieces of data about each person or each year or each country, whatever. Okay, you can collect the data yourself or find it on the internet. This is more applicable to when we're doing it in class, that people could go around and ask each other questions and stuff like that. I think people will tend to find it on the internet on this occasion. I would say make your life easy and use a data set which is easy to work with. So the main thing there will be just the size of the data set. The one I mentioned there, like 12 people maybe in a football team and the manager, or around about 15 people in a squad or something like that. That's a good number. Okay, it's not a huge number. It's not going to take you all day to do the work, but let's say you picked a data set with only 3 people in it. Look, it's just not enough to really write about there. There's not enough to find those sort of correlation relationships. Okay, you could, if you want, to pick a data set with say 100 people in it and fire away if you've loads of time at the moment, but it will take you a good bit of time. So look, I would say between say 10 and 20 maybe data points. Okay, so 2 pieces of information about 10 to 20 people or years or whatever it is you're doing, or countries, whatever. Yeah, again, when doing it in class, I would have said people can do it in pairs, but each person needs to write up and hand up their own assignment. On this occasion, I'm going to say each person needs to do their own assignment. So don't work in pairs on this one. All right. Just some ideas for what you could do. So you could adapt some of the kind of textbook type questions that I would have given you to do all the way back when we did a couple of scatter plots in class before we closed. So I would have got you to do one which was the correlation between the number of bedrooms in a house and the asking price for the house. Okay, well, rather than just doing that on some kind of list that someone's made up as it would have been when I gave you the question, do that for Rush, or do that for Lusk, or do it for Luxury, or whatever. Okay, so go on to myhome.ie, go on to daft.ie, find 10 different houses for sale, check how many bedrooms they have, check their asking price. It will be bedrooms on the x-axis, asking price on the y-axis, and do your scatter plot. Okay, if you're doing that one in particular, or if you're doing any of them, make sure you have a good range of data. So don't just get 10 3-bed houses. Okay, 3-bedroom houses are probably going to be the most common one you'll find, but if you can get 2 bed, 3 beds, 4 beds, 5 beds, if you can get even bigger houses than that, if there are any for sale, do that. But get a kind of range of house size there. It's not going to be, it's just going to be harder to do if you only get 3-bed houses. All right. Exam results in 2 different subjects. That again probably more suits when you're kind of in the same room as each other and you can ask each other questions. Just if you were doing exam results, just one thing to cover off. If you're doing something about junior cert results, when you got your junior cert results back, they would have been in letter grades A, B, C, D, whatever. You can't put that onto a scatter plot. Okay, so scatter plot needs it to be numbers, especially then the correlation coefficient calculator needs numbers. Okay, so if you were doing that one, say, you'd need to convert A's and B's and C's into numbers. Okay, so maybe use the kind of middle point of the percentages that the grades map onto, or use the old leaving cert points to convert them into numbers. Okay, but whatever you're doing needs to be numbers. Height and foot length, height and arm span. That again would have been kind of measuring people in the class when we were in the same room. But I mean, if you can get that data, that information about people, even if it's famous people, or height and weight, for example, of famous people, of footballers, you could do that. Money spent on transfers and goals scored. Okay, so let's say 12 teams, or maybe all 20 teams in the Premier League. How much money did they spend on transfers last year, and how many goals did they score? Okay, is it positively correlated? How much money do they spend on wages in a year, and what was their league position? Is that correlated? Okay, age of second-hand cars and asking price. Just there, you'd need to pick the same model of car. Okay, so there's no point in comparing a new Mercedes to a 10-year-old Ford Fiesta. Okay, so you would need to get the same model of car for last year, year before, year before, year before, and see what correlation is there. Okay, there's a few then. Yeah, it's just different ones. So say, let's say just for this one here, amount a country spends on healthcare and amount it spends on its military, amount a country spends on healthcare and cigarette consumption in the country. This website here, this page on Wikipedia is a good source of stuff like that. All right, so I'll just show you a couple of these websites. When you're doing any of those rankings, per capita numbers are the fairer and the easier ones to use. Okay, so per capita just means per person. Okay, so you need to use those, or else kind of bigger countries are always just way out in front. So any sort of list of countries, look for the per capita numbers. If you want to do something about how rich countries are, that's probably the best bet. There's loads of different measures of how rich countries are. That's the best one to use, I would say, for your purposes. Okay, just to go through then a couple of these websites. So that list of international rankings, that's going to take you to this page here, and you can find countries listed by all sorts of stuff. Okay, so that might be a good source for the thing. For football or sports, well, this is for football statistics. I find this Who Scored website quite good. You'll find them in lots of other different websites, and this is only football, but if football stats is what you're going to do, I think this website's quite a good source for that. The Tyler Vigen one, if people are having difficulty with it maybe and contact me saying they can't think of stuff to do, I might talk more about that one, but I'm not going to cover that one quite now. Just what I want to do quite quickly before the end is a couple of ones that people submitted in previous years. Okay, so this is someone who did the bedrooms and house price. So they've given me their data. That's good. Their scatter plot is clear. It's going up in jumps. Yeah, the scatter plot is good. Correlation is weak to moderate positive. Yeah, that's fair enough. They estimate it. Good. They work out the actual number using that calculator. Good. In conclusion, we had a correlation. However, there were a few outliers. When we got rid of those outliers, the correlation is 0.92. So what I would say there is they didn't name the outliers. Okay, so if you're taking a few outliers, and also if there's a few of them, maybe they're not outliers. Outliers would suggest maybe one or two which are far away. So just if you're saying there are outliers, actually identify the outliers. Okay, so it's this one and that one and the other one, whatever. Okay, I would also say they didn't give me the website that they got that from, but that one's pretty good. Okay, the next one then I'm just going to look at is really good. Okay, so this person did the calories of different snacks and their fat content. Okay, they told me they got it from the Tesco website. That's quite good for kind of information about food. There's all their raw data laid out for me to see. They told me where they got it from. There's their scatter plot. It's quite clear. They describe the correlation. They work out the coefficient. They remove the outliers and work it out again. They tell me what the outliers are, and then they give me the correlation in context, what it means. So the higher the calorie content, the higher the fat content. So they are positively correlated. So that's a really good one, and I'll certainly put that one up for you to